All right, have your homework out if you would, please. We're going to start with numbers 2, 3, 8, 11, and 12 from your Literal Equations 2 non-formulas handout. See how we did on those problems. Question mark.
Yes.
Oh.
I did work.
You did.
I did.
Good for you.
I did not try.
Okay, I see it now. Okay. All right. So some of you have homework passes. You were here for the revival services, and some of you had the homework. So we'll primarily try to call on those who did the work and go from there. Obviously, Kendall and Michael, we are missing you today, and hopefully you will not have a terrible, tragic accident while you're gone from my class. All right, let's take a look. All right. 1, negative AB over X equals 7 over AB minus 49 over ABX. No bitterness here, no bitterness at all. Okay. About people missing my class. Did you know that bottle crush I do? Symbolism in that. It's full, I won't crush it right now. All right, I see fractions. I hate fractions. I multiply everything by the LCD, and the LCD is ABX. So everything gets multiplied by ABX. And when I multiply by ABX, what do I get right here, Genesis?
ABX minus A squared B squared.
Good.
Equals 7x minus 49.
Poof, fractions gone. So we had rational literal equation. Now we have only literal equation. And with literal equations, the key, once they get rid of fractions, if there are any, is to get all of the on one side and all of the non-x's on the other. So what do we do now, Matty? All right, to get? And once we've got it separated out, x's on one side, non-x's on the other, then Audrey? We factor. So on the x side, we should always pull out an x. There may be more you can pull out, but at least pull out the x. And in this case, that's it. It'll leave me with
80 minus 7.
And then on the other side,
You split it up to sign difference.
good.
80 minus 7, 80 plus 7.
All right. And of course, to solve for the x, then to finish it out, Brandon, we would simply
Cancel the 80 minus 7. And then,
there we go.
state that A can't equal.
Or maybe just say that AB can't equal 7. That probably is the easiest way to do this. But our answer for x,
X equals AB plus 7.
there we go. And there's our answer with a little qualifier there. How many had this answer on the first one? All right, all 3 of you who did it. Excellent. All right, let's take a look at number 3. And we've got an A cubed over AB squared minus 2A squared over B squared x equals 1 minus 2B squared over A squared x. And what do we need to do on this problem, Audrey?
You need the LCD.
Which is?
A squared B squared x.
Good. A squared B squared x. I thought for a moment about canceling away the a's here, but then I realized it's not going to change my LCD anyway, which isn't going to end up changing the problem anyway. So why bother? And so we're going to multiply everything, as Audrey said, by A squared B squared x. A squared B squared x. A squared B squared x. All right. And when we multiply through the A squared B squared x, what do we get, Abby?
On the first one you get, and then, so A to the fourth x, cancel the b, and then negative 2a to the fourth equals a squared b squared x, negative 2b to the fourth.
All right, and then what do we need to do, Genesis? All right, so let's move the
A to the fourth x over.
all right, and while we do that, let's also move the
Negative 2b to the fourth over.
all right, so my equation is going to change its look a little bit and say
2b to the fourth minus 2a to the fourth equals negative a to the fourth x a squared b squared x.
I just hate leading negatives, so I'm going to go ahead and put them there and put that at the back. And then once we've got this, we've got the x's on one side, non-x's on the other side, class, then factor, all right? And of course on this side, there's a little more factoring than perhaps normally would be available to us. So let's see here. Maddie, what should we do over here? Pull out a 2, and that leaves us with initially, I'm going to cheat just a little bit, Maddie, because I can tell you wanted to anyway. And so that we're going to take the leftover b to the fourth minus a to the fourth and factor that into and I'm not going to factor this into b plus ab minus a yet, but I could, and maybe I will. Let's come over to the other side, and we can do more than just factor out the x, Genesis.
Factor out a squared and then x. b squared minus a squared.
There we go. And so now you kind of see why I didn't bother factoring further, because I could kind of see it coming over here. That said, if you had a b plus a and a b minus a over here, and you had a b plus a and a b minus a over here, they would both cancel out anyway, right? And that would leave us with a b squared plus a squared, all equal to a squared x, but I don't have x by itself yet, Audrey.
Divided by squared.
So what's my final answer?
2 minus b squared plus a squared
Over,
over a squared. A squared.
sorry, I thought I heard you say b squared over a squared. And we should specify that.
A can't equal 0.
Well, we didn't cancel away any a's. A already can't equal 0, but that is a true statement. It's well, I wouldn't take points off for that.
B can't equal a
Or,
negative.
right, b can't equal positive or negative a. But there would be our answer there. How many got that answer? Maybe with or without the excluded comment there. Okay, question, Genesis?
I did for the negative 2a to the fourth, I did 3a squared.
Oh, right here.
Mm-hmm.
You put a squared with a 2a squared to get 3a squared instead of a squared times negative 2a squared for negative 2a to the fourth. Okay, that makes sense. All right. Any questions there then? All right, let's continue with the next one, which was number 8. A, no fractions. I'm a fan. Oh, plus 9c squared equals 1. So I get to skip the usual first step of multiplying by the LCD. I go to the next step, which is to get all the x's on, all the non-x's on the... How many x terms do I have? 1. This one. You could argue that you could distribute the x, but you just factor the x right back out again anyway. So really all I should do first here, Brandon, is move over the...
Positive 9c squared.
As a...
Negative. Divide by 1 negative 3c.
Well, before I do that, I've got the x factored on this side. Let's go ahead and factor that side as well.
The difference squares.
All right, difference of squares is going to factor into...
Conjugate. So 1 positive 1, no, 3c. And then 1 negative 3c.
There we go. And this side is kind of helping us a little see what we should be doing. And so we just cancel away the...
1 negative 3c.
That leaves with an answer of x equals.
And positive 3c.
But I should specify this can't be 0, so therefore
1 can equal 3c.
1 cannot equal 3c, or maybe even better, c cannot equal 1/3 if I went ahead and divided the 3 away. But it wouldn't take points off if you had the other. There we go. How many had the 1 plus 3c on number 8? All right, good questions on number 8. All right, next one you had was number 11. And a pretty easy common denominator on 11. What is it, Audrey?
AB.
AB. And so we multiply everything by AB, and let's see if we can do this in our head, because it's a pretty easy common denominator. Of course, on the first fraction, the b's cancel, so I really just have to distribute an a. Anyone?
Yes. Minus A squared.
Thank you, Audrey. Then on the next one, the a's cancel, so I just multiply the b. Anyone?
2bx.
Plus 2bx. Thank you, Abby. There's nothing to cancel for the 5, so I multiply the 5 by the full AB.
5AB.
5AB. Let's get some front row or middle row participation. Nobody's on the front row. The a's cancel, multiply the b.
6b squared.
Thank you, Brandon. And fraction's gone. Now what, Maddie? They is on one side. See? They both on this side. Now, I move it, good. Where do I put it on the other side? I put it in the front so we get that descending A, ascending B. It looks like that good quadratic form that we saw before, and that's a strategy tip. You don't want it to look weird. You want it to look like you're used to seeing it, because my next step class is to factor. I want it to look like it normally looks when I factor. Of course, on the left-hand side, that's really easy factoring Genesis. To get, what about on the other side? Good, we're in backwards FOIL here to get.
And both sides and positives. 2 and 3, B.
Good. And outer inner checks, so we can cancel away the. But when we do, of course, we want to set it not equal to 0, so we'll say that
A plus 2B. Is that cancel 0?
and we could say that I would normally move the 2b over as a negative, but again, it's not wrong to just leave it in that form, I suppose. What do we get for our answer for x?
A plus 3B.
A plus 3b. And there we go. By the way, if we were to extrapolate this out a little bit, I want to show this. Since a plus 2b cannot equal 0, a cannot equal negative 2b, correct? And if that's the only thing a can't be, a cannot be a negative 2b, then the only thing x can't equal is a b. There's a lot of other things x can equal, but it will never equal whatever b is equal to because of that. Do you see how you can extrapolate the meaning of that out just a little bit there? So anyway, I thought I'd point that out to you. If you did totally lost you, it's okay, just leave it that way, but I'd share the other for those who can handle it. Questions on 11. How many have this answer? A plus 3b for number 11. All right, questions on that? Comments? Feedback? Even if you didn't do it, any questions, comments, feedback? All right.
I was blind and didn't write the 5.
Ah, okay, all right. Then number 12 was our last one from number 12. We got a over bx, b over ax, and a squared plus b squared. What do we need to multiply everything by here? Abby?
ABX.
ABX. I'm going to be really lazy and risk just writing it once. If we multiply the ABX, of course the BX cancels, and all I'm left with of this class is the A, so I get
A squared.
A squared. Here is the A and the X cancel, so I'm left with a B, so I get B squared. And be careful, lest you say, ooh, it's going to cancel this A squared and that A squared. I also have to multiply this by ABX, and listen, this by ABX. If I multiply both of them by ABX, what am I going to be able to factor out in a minute? ABX, right? This is being smart. S-M-R-T, smart, okay? Why multiply by both of them? We're just going to factor it out again in a minute, especially if we realize that we could group this as a quantity, because it is all one, right? It's all together on one side of the equal sign. And then to get the x by itself, I could cancel away the a squared plus b squared. What's left over here? 1, because remember, you're canceling by dividing it away, aren't you? So when I also further divide away the a and the b, there's my answer for x. Though I suppose I should say that a squared a plus a squared b cannot equal 0. But, question? Would a squared A over a squared B ever equal 0? Added together? Because when you square something, you always get a positive, unless the A is 0, right? You'd never square a B and get anything negative. Unless it's a 0, then you can get a 0. So I suppose if both A and B somehow equaled 0, then we would have to worry about it. But A and B already can't be 0. So technically, again, probably the safest thing is just to write that unless you understood what I just said. But technically, we don't have to write that. X just can't equal 1 over A or 1 over AB. And we get that answer, 1 over AB for this one. All right, Audrey, good questions on this. Do you see the shortcut? Again, is it wrong to say A cubed BX plus AB cubed X and then factor out? No, absolutely not. But I just wanted to show you shortcuts because mathematicians are lazy. Questions. All right, let's take a look at some word problems together now, and then we'll go back to our handout to kind of wrap up this material here. And we looked at problems like these in Algebra 1 where we separate things into parts. Now, geometry students have a little bit of a leg up because when you hear parts, there should be a phrase or a sentence, I guess I should say, that rings in your brain when you hear parts. Are you thinking what I'm thinking, Genesis, or have you purged it from your memory? The whole... She drops her pencil to avoid answering the question, but I'm not letting her off that easy. So Genesis, as you struggle to pick up your pencil, the whole is equal to the sum of all its parts, right? In other words, if there's a pizza and it's been chopped into 8 slices, if you come back and there's only 7 slices, the whole pizza is no longer present. Maddie has been through, right? Okay, the whole should equal the sum of all of its parts. Well, here we've got a number 44, and chop it into 2 parts. And the difference of the 2 parts is 16. Well, how many unknowns do we have then, class? 2. We have the party of the first part and the party of the second part, as they say in legalese. And how does it compare the 2 parts to each other? Their difference is 16. It doesn't tell us which part is which, so we could call either of the parts, class, x. And the other part could be x minus 16 is the most logical way to represent it, so that there is a difference, subtract, of 16 between them. Now, technically, if you added 16 to this one, you would still have a difference or a gap of 16, wouldn't you? But I prefer the x minus 16, so I like what Abby said there. But we know that the whole thing, the whole of anything, is equal to all the parts added together. So if I want to get the number 44 again, I'll take the first part, I'll add the second part to it, and when I add the 2 parts together, poof, there's the 44 again. Does that make sense? So when something's been divided into parts, if you'll simply add the parts together, it'll give you back the whole thing you started with. Make sense on the equation? We combine like terms, class. 2x, we add the 16 to the 44, and we end up with x is equal to 30, which means that one of my parts, I called it the first part, is 30, and the second part apparently 14. Sure enough, there's the 2 parts of the number 44 that have a difference of 16. Now, had you said x plus 16, then you would have combined to get 2x. You would have subtracted the 16 to get a 28, and you'd have gotten x is equal to 14. Well, that means your first part would have been 14, and your second part would have been 30. Same 2 parts either way. Does that make sense? Questions on what I call a parts problem. Add the 2 parts together, you get the whole thing. Questions? Here's another one for you then, at your seats. Obviously 2 unknowns, right? Part 1 and part 2. How do we represent the 2 parts, Brandon?
X and 3.
How many had x and 3x, or 3x and x? Doesn't matter the order. So what's the equation going to be, Genesis?
4x.
Equals?
4x equals 4.
4x equals 40, right? Add the two parts, 3x plus x to get 4x has to equal the whole thing you started with. So obviously x class equals 10, and the two parts are 10 and 30. Any questions? Here's another problem here. Go ahead and read it for us if you would. Maddie? How many unknowns, class? 2, and they are first number and some second other number, right? So I'll just say number 1 and number 2. How should I represent number 1 and number 2, Maddie? X and 8x, whose one number is 8 times another. And then it says that their difference is 28. How should I write that equation, Maddie? Good. Difference, remember, means to subtract, so 8x minus x is 28. Or in other words, we could combine class to get 7x. You might have started with this, that 7x equals 28. Easily solve it in your head. X must be 4. So my first number is 4, and my other number is 32. Sure enough, one number is 8 times another, and their difference is 28. Questions on that one? Take a moment to read it. How many unknowns, Audrey? I'm sorry? 2? What are they?
5x and x minus 1.
I've only got one unknown. I've only got one thing we're finding. 5 times some certain number, there's one unknown, is decreased by 12, the remainder is 13. What is that number? What is the number? So I've only got one unknown. And remember, if there's only one unknown, class, literally the whole problem is just algebraic representation. So represent that statement algebraically. We'll go back to Audrey for redemption here. Just one unknown. Okay, mixing it up just a little bit here. Audrey, what's our equation now?
5x minus 12 equals 13.
Right, 5x minus 12 equals 13. In our heads, we're going to do what first?
Add to 12.
To get,
25.
and then divide by the,
5.
to get what number?
5.
5 as our answer. 5. How many had that on this word problem? Questions on these word problems. We'll keep working on these in the days ahead. Going back to your handout, I want you to do number 14 at your seats. Number 14 there at your seats on the handout. This is a special type of problem. What type of rational equation is this? Class? It's a proportion. So what's the best way to solve this thing? Cross multiply at your seats. Okay, a rational equation, class, is an equation with or fractions, right? A literal equation is an equation with extra letters in it, right? And of course, most of the things on this sheet are both rational and literal. You have lots of extra letters and there's fractions. Twice the fun. So much fun that Michael and Kendall felt the need to miss school today. But I'm not bitter. Michael and Kendall. I would even grieve if your shotgun blew up when you tried to shoot you.
That's sweet.
If you fell out of the tree stand, I would feel bad for you. I would. I'm not bitter. Gavin's like, see, I'm a diligent student. I'm working on my algebra in the deer state. I don't even know if they have deer in Japan. All right, when we cross multiply, what do we get for our new equation, Genesis?
2a times x minus 4a.
Okay, you already factored it. I was just going to go 2ax minus 8a squared x, like that.
Okay.
That's all I was going to do, was just literally distribute through, and it is equal to
cx minus 2c squared.
All right, and then we can worry about factoring stuff. Wait, not a squared x, 8a squared. I don't know where the x came from. 2 times ax is 2ax. 2 times negative 4a squared is negative 8a squared. All right, I was just seeing if y'all were paying attention. I heard a noise of desperation back there. All right, we're good now? All right, yeah, so there was trauma. Abby was about to go into, what do they call it, cardiac arrest or whatever?
I got it wrong.
Yeah. All right, so Abby, now that the world can revolve on its axis properly again, the planetary wobble is fixed. What do we do?
You move the cx over as a negative cx, and then you move the negative 80 squared over as a positive 80 squared.
All right, and as the world goes round here, what do we end up getting?
2ax negative cx is equal to 8a squared negative 2c squared.
All right. And it wasn't, I think of that will wobble, like Margaret Thatcher, remember, she's the one, I think it was No Time to Go Wobbly, right? This is no time to go wobbly. Can't remember, I think it was Ronald Reagan, I think is who she was talking to. There was all kinds of crises in the world left behind by the previous administration, just really bad foreign policy by the US, and even Great Britain had really had some struggles. And so a crisis comes up, and she tells Ronald Reagan, this is no time to go wobbly. And if only we'd had someone giving that advice, perhaps, in Afghanistan recently, we would have seen some of that crisis averted, right? But instead, people hid in their basements and people died and held hostage now, and it's really bad. But anyway, getting off politics, back to this. What do we need to do in this equation now? Brandon? Factor.
The x out, 2a minus c, and then 4a squared minus c squared. That's like the squares.
Okay, he wasn't going to let me get to the next person. I'm going to keep the x and the 2a minus c, but over here.
We bring them to, and then 2a positive c, and then 2a minus c.
And of course, that works out great for us because now we can cancel the
2a minus c.
And so my answer for x, all of y'all are working along with us, right? Or you've done already. Maddie's like, I'm done. Duh. All right.
X equals 2 times c plus 2.
So disrespectful now. All right, and what qualifying statement should we? I'm putting words in your mouth. What should we write in addition to our answer?
2a minus c can equal 0.
Okay, fine. I was going to say c can't equal 2a, but we can just write it that way, I guess. I already have that answer. Those who were already done, sitting there just waiting on me to finally finish.
Yeah.
Number 16. We're just working at your seat since you're so fast. Number 16. I'm not upset at all. I like fast. Fast is happy. I can dig out my answer key and just ask you what you got. And here I've got a little issue, don't I? Right? We distribute the b, no problem there. Agreed. We bring the bx over with the other x. We send the 1 and the 4b over in descending order so it's easy to factor. But I can't cancel anything yet. What could I do to allow myself to cancel? If I were to pull out a negative and pull it all the way to the front, that could make this negative and that positive. Remember, you don't affect the negative to both, just one or the other. Now I can cancel the 1 negative b and the 1 negative b. So my answer for x ends up being
negative 3b plus 1.
negative 3b, negative 1. Or if you distributed the negative 1, negative 3b, I suppose it wouldn't be wrong to say negative 3b positive 1. Any of those answers would work. We should specify, though, this can't be 0, so therefore 1 cannot equal b or b cannot equal 1, which means there is one specific answer you cannot get for x. If b cannot be 1, x cannot equal negative 2. Because if you plugged in a 1 here, you would get a negative 2, and that's the one thing you can't plug in for b. That's the one thing you can't get out for x. Questions on this with the factoring out of the negative? We haven't seen that for a little while. Questions? How many got it? You got it. Okay, good. Brandon, way to represent guys. All right, all the other guys who aren't here. And then ladies, questions? All right. Number 17. Number 17. Oh, 3 times I'm going to have to do what, class? Square the first, square the last. Oh. What?
Take her up.
She's not going to be favorite student that way. But at least you're here. Unlike Kendall and Michael. But I'm not bitter. I'm not bitter. I won't hope that Kendall falls out of the tree stand or anything. She can't get in the tree stand. You can't reach. Picking on Kendall. Unless your dad doesn't take you hunting. Brecken's like checking the date stamp on the YouTube videos, like, oh yeah, I didn't watch a lesson that day either. I was hunting too. Ah, yeah. All right, check your work. Square the first, square the last, multiply and double is x squared negative 2ax positive a squared. Square the first, square the last, multiply and double is x squared negative 2bx positive b squared, but there was a negative sign in front that I had to change every sign in the PST. Square the first, square the last, multiply and double a squared negative 2ab positive b squared. Questions on the initial step? All right, from here I saw the x squared negative x squared could cancel. I saw the a squared here and the a squared there could cancel, but the b squares don't. Okay, they're not perfect matches. So I've got a negative 2ax and a positive 2bx, which I kind of thought of, frankly, as a 2bx negative 2ax with the positive before the negative. So I factored out the 2 and the x, I was left with b negative a. Okay. And then I brought the negative b squared over here to get a positive 2b squared. But again, I wrote the positive before the negative because I don't like leading negatives. 2b squared negative 2ab. Factored out a 2b, left with b negative a. b negative a's cancel, b can't equal a. 2's cancel, x just equals b. And as long as b doesn't equal a, x can equal anything. It's just x can't equal a then. Didn't we get x equal to b? All right, good, several of you. Good question. Questions? clear desk, except for a clean sheet of paper, a pencil, and a calculator. Clean sheet of paper, pencil, calculator, everything else away. First last name at the top of your paper, along with today's date, which is 10/22/21. 10/22/21 today's date. And this is quiz 12. Obviously, Michael and Kendall will have to take this quiz when they return to us on Monday. Let's go and take a look at the quiz together very quickly. Numbers 1 through 3, answer the questions. Numbers 4 through 6, solving for some formulas. Numbers 7 through 11, you've got, notice 10 and 11 have multiple letters in them. Notice 7 through 9 don't. Okay, so more like some of the other equations we were solving just before these. And there is a word problem. Write the equation and solve. By the way, I want you to notice on number 12 the word from. Just thought I'd point that out. All right. I'm going to write the homework on the board and then I'll end the video. Students watching the video will end soon.